Okay. Sveiki, esu Edgaras Dunajevas iš Credit Information Group ir čia yra jau ketvirtas Kit Club Coast Data Science. Labai malonu matyti daug jau pažįstamų veidų, kurie čia jau ne antrą ir ne trečią kai kurie kartą. Praeito pristatymo žvaigždė Giedrius, bet ten Mantas visada dalyvauja. Bet dar maloniau matyti daug nematytų veidų, susipažinti su naujais žmonėm. Ir tiesą sakant, mes tikėjomės, kad šis pristatymas bus populiarus, nes Data Science yra čia toks buzzwordas ir čia viską. Bet nesitikėjom, kad bus tiek daug žmonių, kas yra džiugu, bet čia nekalbant apie jūs, bet ir apie pranešėjus, nes tikėjomės, kad bus sudėtinga galbūt surasti, Kaune gal nieks nedirba, atsivežėm pristatyti iš Vilniaus, bet tikrai yra dar 3 ant suoliuko, kurie nori pristatyti savo temas Data Science Kit Club'ui ir kadangi jie netilpo, tai darysim dar panašų pristatymą ir kitais metais. Taigi, o dabar kadangi kai kurie čia, kaip jau sakiau, yra nauji žmonės, tai trumpai pristatysiu, kas yra Kit Club'as. Aišku, jūs čia atėjot, tai jau tikriausiai šitą girdėjot apie mus, bet Kit Club'as yra Kauno IT bendruomenė, jungianti IT profesionalus, studentus, kitus geros valios žmonės, kurie domisi naujomis technologijomis ir ateina čia susipažinti visų pirma, išmokti kažką naują, išmokyti kitus, papasakoti savo patirtį ir gerai praleisti laiką. Tai va, čia mes dar tikiuosi gausim picų, kolos ir visiems bus mūsų dar smagiau. Taigi, dabar mes visi turėtume užsiregistruoti Facebook.com groups Kit Club'e, nes tenai jūs galėsit pasiūlyti savo temas kitiems renginiams, pasisiūlyti padėti savanoriauti galbūt, arba jeigu jūs tai įmonės atstovas, tai galbūt net norėtumėt prisidėti prie organizavimo ir finansiškai. Čia viskas apie tai parašyta, o dabar mes galime eiti prie šios dienos renginio. Aš papasakosiu, kol Artūras atsidarys. Tai šios dienos renginys prasidės jau už kelių minučių. Pirmas pranešėjas bus Edgaras Dunajevas iš Oberlo su tema Data Science ir amžinais klausimais What, Who, When and How. Po to turėsim pertrauką, kaip jau minėjau, su picom ir pasišnekėjimais. Toliau šnekėjęs Jonathan Hill iš Credit Information Group su topiku On Becoming a Data Scientist, kas yra labai aktualu, čia mačiau tokių labai perspektyvių ateities programuotojų, jaunuoliai sėdi. Ir paskutinė tema yra Giedrius Dunajevas ir Simonas Stepanovas iš ICBit startupo. Jie papasakos apie savo kelius ir kelius, kuriant Geospatial Data Clustering Engine. Tai 9 valandą turėtume baigti ir dar kviesiu visus pasilikti, pasišnekėti, pasidalinti įspūdžiais. O dabar naujovė. Turėsim prizų. 3 bilietai į Highland Strategy konferenciją, kuri vyks jau spalio 14 dieną. Pats dalyvau praeitoj. Šiemet panašu, kad irgi bus gera, tai kviečiu visus dalyvauti. Mes padovanosime, tiksliau Atformas padovanos 3 bilietus į tą renginį. Ir kad ten dalyvauti, užtenka pabūti šitam renginį iki galo. Gal kaip nors ištversit. Ir tada mes iš visų, kurie Facebook'e padarė attending, dalyvausiu, išrinksime nugalėtojus. Tai kas dar to nepadarė, tai kviečiau dabar tai padaryti. O po to išrinksime 3 nugalėtojus. Aš tikiuosi, šitie rinkimai bus sėkmingesni negu Lietuvos kitimas. Ir dar, jeigu būsite aktyvus ir uždavinėsite teisingus klausimus, pranešėjimams dovanosime ir Kit Club'o maikutės. Panašios, gal dar gražesnės negu mano turiu. Visi, kurie nelaimėsite, nusipirkit, galit gauti 30% nuolaidą, panaudoję nuolaidos kodą HighLoadLT į HighLoad Strategy konferenciją. O dabar, kaip jau minėjau, pagrindinis organizatorius ir sponsorius yra Concrete Information Group, yra Atformas. Prašom padėkokit rėmėjams, kad be jo šito renginio nebūtų. O dabar pažadu, paskutinis klausimas, daugiau nebešnekėsiu. Kas iš jūsų susiję su data science, su machine learning arba data analysis, kas su to dirba? Pakelkit ranką. Rimtai, tiek daug? Geras. Tai gerai, šią linksmą gaidą, prašau sutikite pirmą pranešėją, Edgaras Dunajevas, Oberlo.
Ar gerai mane girdit? Tai savo pranešimą anglų kalbą skaitysiu, nes taip yra paprasčiau, nereikia visų tų sudėtingų terminų versti. Ir beje, gali būti žmonių nebūtinai lietuvių tautybės ar lietuvių kalbos. Taigi pradėkim. Šiandien noriu papasakot apie tokius 4 pagrindinius, mano manimų, klausimus, su kuriais susiduria žmonės iš verslo pusės ir iš data science pusės. Tai yra data science what, who, when and how. So I've added one slide about me because probably nobody knows me. So I'm 27 years old. I used to play tuba in the school's marching band, so probably wanted to become a musician. Then I made a switch to math and stats. 5 years ago, I decided to go into data science and do it for a living. Now I'm a data scientist and Lithuanian rockstar e-commerce automation startup Oberlo. When there's spare time, I record music, and I hate driving. This is because I came today by train. So this presentation, like I told you, is going to be about 4 things. So first of them is we're going to talk about is data science a new trend? Should your business start looking for data scientists and what problems they could solve for you? Is it safe to trust data-driven decisions, and can data science predict the future? If you have any questions, please raise your hand. I'll happily answer them during the presentation or after. Okay, so let's start. Is it a new trend? So 4 years ago, 1 year after actually I decided to become a data scientist, I saw this article in Harvard Business Review. So it had this really nice heading that the data scientist will be the sexiest job of the 21st century. But even before that, chief economist of Google said that statisticians will be one of the sexiest jobs in the next 10 years. So I guess statisticians now have like 3 years, right? And then maybe the trends will change. But right now, statistics is one of the key parts of the data science. But it was said quite a long time ago. The modern term, data science itself, there was a first modern reference about it 15 years ago in one of the Bell Labs papers. It was about how statistics should incorporate all the advances with computing with data. Also, there were these 2 guys, Jeff Hammerbacher and DJ Patel. One of them, Jeff, is founder and chief scientist at Cloudera, and DJ Patel works for the US government, White House. So we're kind of credited for coining the term and making it popular on social media 15 years ago. So an interesting thing was to look at how data science compares to machine learning trends and big data trends. So we can see, is there a laser pointer here? Probably not. Anyway. Okay, so we see like big data was kind of rising since 2009, but then right now it kind of reached its plateau. Like it doesn't have this kind of big growth like it used to. But data science and machine learning are now steadily growing and becoming more popular. So I would say that these kind of things, they've been there for a while, but they're starting to trend up finally. As we can see that you guys organized this nice event here in Kaunas, so I was really delighted to come and give a speech here. So what is data science? So this is like a really classical graph. It basically shows what it is. So data science is hacking skills, math and stats knowledge, and substantive expertise, what basically is a business problem and how what incorporates business into the science. So if you take all of these three things together and join them, you get data science. So here you have machine learning, traditional research, and here is the danger zone. It's when you know the business, you know how to hack stuff, but without statistics, you're in a danger zone. What I wanted to add to this classic image is like right now, communication and visualization skills are really important because a lot of things that you model or base decisions on data, you have to communicate them efficiently, you have to visualize it, and you have to be able ordinary people to understand them effectively. So I guess it's also adds up to all of these circles, and I would say sometimes like your communication and visualization plays key part in all the research that you're doing. So just to recap, so data science has been there for a while. I even saw an article recently in the TechCrunch which said that Buddha was a data scientist. So basically he was doing a lot of empirical testing of the phenomena you would think about. It's trending right now. All the components of data science have been there for a while, and without math and stats, once again you're in a danger zone. So okay, any questions so far? Okay, so let's move on to the next part. So imagine you are a business and you think, well, I have all of this data, about my users and everything. Should I hire a data scientist? So first thing you have to think about is what kind of business problem you're trying to solve. It's not going to work if you're going to go to data scientists and say, hey, I have like terabyte of data, can you do something about it? Because data scientist, he will come, he will be new, he won't know he won't have the business expertise, and you'll just waste a lot of time and money in getting him to know your business. So you have to formulate this problem yourself. So instead of that, you should know what you're doing. So for example, you want to build a recommender system to retain more users. So this sounds more like a solvable business problem, and data scientists, oh, okay, I know how to make recommendation engine, so I'll help you. So you have to know that it takes time. It's hard to estimate project duration. It's hard to estimate project duration when you're developing stuff, but when you're doing data science, it's even harder. It's also, like I talked before, it's hard to get a new data scientist to grasp and get to know what your business is doing. It takes time. And you have to know that it can be expensive. So one thing is that it's hard to find people with good skills. I've been working in Adform for 3 years, and we built data science team from 2 people up to, I don't know, 30 something across 4 different countries. So we had to do a lot of interviews, and it's kind of a hard thing to do to find people with a good skill set. Not even in Lithuania, everywhere I would say. Also, cloud is expensive, right? So if you're a new business or a startup, it's a good idea to go to cloud, and you have all the possibilities to scale up. Everything's made easy for you. Just one button click, you can scale out, but it's expensive. When you become big, it becomes expensive, and companies spend a lot of money in trying to optimize these cloud costs. So one of the alternatives, instead of just going out there and hiring data scientists, is outsourcing to some companies which do this kind of a data science consulting. In Lithuania, there are a few companies, I don't want to mention their names anyway, but pros of that is if you know what kind of problems you want to solve, it can be cost effective. Also, people might be solving similar problems as you have, so it might be shorter in the execution time. And I think it's really good for short-term, one-time projects when you just want to test it out, whether it works for your company or doesn't. Cons are, again, if you don't have this problem that you're trying to solve, it's gonna be expensive. Because making data scientists come up with what kind of value you should bring to your business, I guess it's not the best idea. So it's difficult to evaluate the complexity of your problem because you're not a data scientist and you don't have data scientists in your company. Also, after the project is done, it's kind of, you have to define service level agreements, who's doing the maintenance, if for example you're running some kind of recommendation engine or some prediction engine. Also, you might not know how to evaluate quality, and a lot of details when the project is finished might be swept under the carpet, and you might find out interesting stuff after a long time passing. Other alternatives, I guess this is what we tried in Adform. It's a good thing to take people that already been working with you, encourage their self-education. But the key thing here is not to start with very complicated problems. Maybe start a business intelligence team and build up more complexity on top of that. And also make sure that you don't fall into this danger zone when you're, vulnerable to all the things that you don't know about the statistics. Also, it's nice to seek for young talent. We have a lot of people in universities. The only thing is that who to choose, and it's kind of hard to predict who's gonna be good and who's not. And a lot of young people might want to leave after some time when you get the experience, for example, to develop their own things. This is what I actually also experienced. Okay, so seek for young talent, teach them how your business works, and also be prepared for them to get away if you're not careful enough. Also, I wanted to talk briefly about cloud and tools. So, working with big data and data science, there are close to 300 projects in the Hadoop ecosystem, and it's still growing. So it's all open source, and so you don't have to pay anything for that. It's changing very rapidly, so you have to be up to date. So, and finding people who are up to date with all of these changes, it's also a hard thing to do. So, also I wanted to talk about Amazon Web Services costs. So, it seems that you would pay $30 per month for 1 terabyte of data. So, imagine you have 1 terabyte of data coming in every day. So that's multiplied by 30, so it's $900. And I picked out one of the classic machines to process this data. So running it for a whole month, maybe you wouldn't be running it 24/7, maybe you would run it once a day with 24 machines. It would still cost you the same amount of money. You would pay with storage and this basic kind of machine setup $1,000 per month. So it's not a lot, but it builds up really quickly, and this is I guess why we in Netform moved out of cloud after some point when we were spending just too much money, and moved to bare metal and tried to use different kind of technologies. Okay, so the takeaways in this part is a lot of data is the only thing that you don't expect that data scientists will make you golden. Also avoid people who might get you in the danger zone, avoid people who are using this kind of black box approach and overusing word algorithm in each sentence. And before hiring, you just try to figure out what kind of file you're trying to create. I guess this is the most important thing here. Okay, any questions? All right. So right now I'm going to move to a little bit more scientific parts of my presentation. So first of them is like, can data help in making decisions? So first example here, I just wanted to ask you a question. We have stats of Michael Jordan and LeBron James, 10 seasons of their careers, and we have 3-point percentage and 2-point percentage. So who is better? Who do you think is better? Yeah. But when we pull this data together to field goals, we see that Michael Jordan has 51% field goal percentage and LeBron James has 49% field goal percentage. So before we were counting 3-pointers and 2-pointers separately, now we pull this data and we kind of get different kind of inference about who is better. So this is called Simpson's paradox. So the trend appears in groups of data, but it disappears or is reversed when groups are pulled together. So here I have two examples. So this one is IQ and alcohol intake. So if you pull all the data together, you see that with increased alcohol intake increases the IQ, which is like a genius thing to publish in some kind of media. But if you look at the data for each of the individuals, you see that really what happens is as when you consume more alcohol, your IQ drops. So this one is more interesting because you have neuroticism in coffee. So we see that when the data is pulled together, we have this kind of positive correlation between these two variables. But when we look at males, we see that the less coffee males intake, the neuroticism increases. So for females, we might make a good inference, but for males, we wouldn't. So what I wanted you, so the first thing here is like about making decisions with data is, you should always try to look for the natural groupings in your data and maybe try including them in your model and see how it behaves. Because you can usually run into this problem of Simpson's paradox, and a lot of people, when for example they calculate churn rates for their clients, they don't take into account like that churn for like new users is much higher than for users who are successful or use a system. They are experts in the system. So this is a thing you should account for. Also, an interesting topic, since we were kind of investigating correlations between alcohol intake and IQ, I wanted to talk about correlation and causation. So correlation is a dependence between two variables, while causation is one variable is responsible for change in another. It has a direction, while correlation does not. So correlation does not imply causation, and it's really important thing when you reason about something. So I wanted to show you some examples of spurious correlation. So here we have per capita cheese consumption, and it correlates with the number of people who died by becoming tangled in their bed sheets. Another nice, so it has 94% correlation. Another example is films, Nicolas Cage appeared in a number of people who drowned by falling into a pool. So it has a lower correlation, but you would say that it's like significantly positive. So what is a causation? Causation, it's like you have a direction between processes. So A causes B, and if A causes B and A causes C, then B and C might be correlated, but neither B causes C nor C causes B, right? And there can be many different combinations of that. You know, we could have this kind of causation tree when you have really complex relations. So here I wanted to tell an example. So imagine A is the sun, like high temperature. So the sun causes ice cream sales. Sun also causes sunglasses sales. But so we see that sunglasses sales and ice cream sales are correlated. So okay, I say, I hate this ice cream guy and I own a sunglasses shop and I'm just gonna close my shop so nobody's gonna buy ice cream. But it's just stupid, right? So nor the sun's gonna stop shining when I close my sunglasses shop. So it's like a really simple example, but if you were to take more complicated things like, for example, cancer and smoking, number of people who have cancer and number of people who are smoking. So some people might say that, you know, we want to determine whether one of them is, maybe smoking is causing cancer, but it's not that easy to prove that. Or for example, when you have a political party and you have economic growth, like during some period when this party was elected, we had like really good economic growth. When the other party came, we just had nothing, and it was an economic crisis. But there might be other, you know, processes which are causing this kind of change in the economic growth, and the political parties don't even have to do anything with it. All right. So correlation does not equal causation. Another thing which is called black swans. So this term, I guess it became more popular after financial crisis. So it's known that we tend to underestimate probabilities of rare events. But what's interesting is that once we observe these rare events, we still rationalize that they could have been predicted. You know, after the economic crisis came, there was a bunch of articles who said, yeah, we could have predicted this economic crisis. But why didn't you do it before it? Why can you do it after? So we kind of have this false confidence that we can predict these rare events, but actually we don't. So I just wanted to illustrate it by comparing two probability distributions. One of them is, the blue one is bell curve or the normal curve, and the other one is Cauchy. Cauchy is usually used for some kind of extreme value modeling distributions, and bell curve is used like everywhere, right? Because we base a lot of our assumptions on that. We say that our model errors are distributed, we have a normal distribution, and etc. So just to compare like behavior of these two curves. So for the standard bell curve with mean 0 and standard deviation 1, there's a 99.7% chance that its observation will lie within -3 and 3. So for Cauchy curve, this probability is only 80%. So like one out of five observations would be considered as an outlier here. So, and this Cauchy curve, you looking at the graph, you could say, well, it probably has mean of 0, but it doesn't even have mean. It has infinite mean. So it doesn't have mean. It doesn't have variance. So it's like it's used for modeling these kind of shock events and rare events. So yeah. Okay, and there are many other things which our statistics are fighting with. So one of statistics and machine learning and data science. So it's overfitting, curse of dimensionality, bias variance trade-off, look elsewhere effect. This one you might not know what it is, but it's basically it's when you see a statistically significant result in your test, but actually it happened by chance. There are bad visualization techniques which ruin making our decisions. So when we're using 3D pie charts, endogeneity, collinearity, heteroscedasticity, sample selection bias, and missing data, all these things, they kind of ruin our decision making, and not accounting for them, we can make wrong decisions. So, conclusions. Account for Simpson's paradox, correlation does not equal causation, and rare events happen more often than we think, and before making any decisions, we should understand the assumptions of the model we're using and test if these assumptions are valid, and then change our model to work well for us and help us really make these data-driven decisions. Okay. Is it a signal that I should stop? Maybe I'm going too fast. Okay, it seems to be alright. So the last part of my presentation, so I wanted to talk about prediction and forecasting. By the way, does anybody know what's the difference between prediction and forecasting? So some time ago, prediction is what you would get a prediction if you would go to some kind of gypsy lady and ask what will be my future. And forecasting would be like Roman general, estimating how to put his forces somewhere and attack somebody. So, and right now, difference between prediction and forecasting, I guess these are synonymous words and we use them interchangeably. But still, forecasting is more associated with time series, it's more associated with some kind of interval of the time, while predictions can be also forecasting, it can be even more than that. But I guess you can use them interchangeably. So how good are we at making predictions? This is a really fun graph, which a lot of people could argue with me. They would say like we are much better in online advertising, or we are much better in predicting finance. But it's just like I just randomly, well, not randomly, but I put this there just to get some sense how accurate we can be and how hard some things can be to predict. So let's take, for example, online advertising. So it's kind of easy to predict whether users is going to click on the ad or not, while if you want to make kind of more meaningful prediction, which is if a user is going to make a purchase, it becomes a much harder problem. So it makes sense. Okay, so things that work quite well here, we could put click prediction also in this place. So things that we see work quite well is a face recognition, like we put a photo on Facebook and we immediately see a square. Well, sometimes we see a square over some cow's face, but it rarely happens, but it happens. Also, our spam filters are quite nice, but we don't notice it because we don't get any spam. But under the hood, there's a lot of spam circulating everywhere, and spam filters are working to help us to avoid getting all this kind of spam emails. Movie and music recommendation. Well, I tried, let's take Spotify for example. So they have this feature when you can like some song and then it will adjust the radio. And sometimes I didn't like all the songs and it would start playing Mexican music to me. But I'm not a fan of Mexican music. So they have all these kind of sorts of corner cases which don't work well, but for like a general user, I guess there's some value in like how we recommend movies on Netflix or songs on Spotify. The things that are very hard to predict is finance and earthquakes. So finance, I don't know, it's just like very random thing sometimes. Well, sometimes it's kind of easy to make predictions if your stock is going up or down, but sometimes it just seems like too much randomness here. And like the hardest thing, in my opinion, to predict is when the earthquake is gonna happen. We're kind of advanced in that, but we still are not very accurate at it. Okay, another interesting article I spotted over the years is that, well, it was 2012. So Target predicted that a teen girl was pregnant. So, and everybody went nuts. You know, Business Insider wrote about it, Forbes wrote about it. So the first thing, do you have any idea why would Target want to know who's gonna become pregnant?
Because it's a gold mine.
Yeah, because it's a gold mine. After parents have a baby, they go to the shop and they buy everything. They don't care about the prices too much. They buy big quantities of things, and you kind of want to establish this relationship with your customer before baby gets into labor, and keep this kind of client because it will bring a lot of value to you. So Target has like millions of users in the United States, and it has a lot of data about them. But I don't think that there was anything very sophisticated about this model. So what it was really about. So usually when the woman becomes pregnant, she hates the smell of scented products. So she kind of chooses neutral smelling products oppositely to shampoos with scents. So this kind of change of habit is a really strong signal that somebody is pregnant, and you can figure it out pretty quickly. Also, you can start consuming some random things that you never consumed before. So you can put these two features along with each other, and you would get a pretty good model in describing who might be pregnant or not. So as if media made this like it was a miracle happened, like somebody predicted pregnancy, it wasn't that big of a deal, right? So here I want to talk about a thing which is called publication bias. So we know that statistically significant results have been shown to be 3 times more likely published than papers with null results. When null results, it means that the researchers tested control and treatment groups, and they haven't found any difference. So if you don't have any kind of this significance in your paper, it is less likely to be published. So we observe similar thing in media and social networks. So there are far less articles about how somebody fails to make predictions, how somebody spends a lot of time on solving some problem, but then nothing comes out of it. And this it creates a false sense of confidence that we are really good at doing everything because we see all these articles. Target can predict who's pregnant and etc. We can predict who will win the elections, but usually these articles about winning the elections, they get published after the election happens. Nobody wants to publish them before. So what is a good prediction? So here I have 4 cases. So precise is not like a machine learning word here. Precise is like basically you have a point precision of a number. So for example, before the financial crisis, you would rating agencies would classify CDOs, which are kind of a lot of loans pulled together, and they would classify their probabilities as being kind of defaulting being low, and they classify these probabilities with like high point precision. So they were not accurate, but they were precise. But as it turned out, all of these loans were correlated with each other, and when somebody defaulted, then more people started defaulting, and then everyone went into financial crisis. So here we kind of were precise about making our calculations, but we were not accurate. So the ideal case is when you're accurate and precise, when you have low bias and low variance. And here, this is the case when you're not accurate and not precise. So it's important to measure these things when you model something. Because, for example, if you are not accurate but precise, you have a high bias, and you say, hey, wait, no, our predictions are kind of doing wrong. Maybe we should add more data to it, right? So it won't help it in this case because your model is biased. If you're accurate but not precise, adding more data would help you, make better decisions. So it's important to monitor this kind of things and understand them about your models. Also, I wanted to talk about prediction KPIs. So I listed out some of more popular ones. So it's accuracy, lift, log likelihood, relative information gain, precision and recall, F1 score, area under curve, ROC, and I wanted to talk about lift. So this I took from a web page of one company which does this kind of data science consulting. So we say that churn rate was reduced by 10%. So the lift was 10%. So this number by itself, it sounds amazing, right? 10%. But what happened is actually we dropped churn rate from 2.4% to 2.2%, which is kind of still impressive thing. They did some improvement, but you have to understand that your sales won't go up by 10%. Well, not necessary, but most likely they won't go up, even though Lyft says everything is cool. So when somebody's presenting their results, you should ask for other metrics just to see what kind of things are going on, and just having single KPI is not a good idea to evaluate model accuracy or improvement in the whole system. So do I still have time? No? All right, so just quickly, I laid out some rules of thumb for prediction metrics. So don't use a single metric. Don't use a lot of metrics because it will be really hard to choose which ones you're going to monitor. Don't be afraid of cases when your metrics will disagree. You have to analyze them. If something is too good to be true, like we saw with Lyft, 10%, do further investigations. Also prefer value metrics if you can measure what kind of value you're creating. Use them. Also combine this with scientific metrics that will give you more insight how your model works. Also calculate confidence intervals when it's possible to see if you're precise. Rules of thumb for making predictions: avoid black boxes, like we told you, avoid this danger zone, avoid overcomplicating things, start with basics, build up complexity, measure progress and compare. Always think about how you're going to scale, because sometimes you might get a nice model, but it's not going to scale. And there's no silver bullet for every problem. You have to try different tools and be open. Thanks.
Could you define the skills that the data scientist should have? Also technical and maybe soft skills.
Okay.
From your own experience.
From my own experience, it really depends. It really depends in what is the size of your team. So if you're alone, you'll have to have a pretty broad skill set. You have to know databases. You have to know, MapReduce maybe. you have to know all the stats and everything. But people, sometimes they build data science teams, so we have an engineer, we have a guy who does the visualizations, we have a guy who does the modeling. So I find that these teams who have various skills of different people, they work really nice. So, but there's no like a general answer what you should know, because all of this technology is like really changing all the time. So you'll have, well, the most important thing I think is like you have to be constantly learning new things. The question was like what skill set should the data scientist have?
Dar kas nors?
What is your usual work day? You go to the workplace, you start from something, you go to meetings, make calls, or you're just sitting at the computer, like what is life from day to day?
What's my typical day at work? So I would say it's like random. So last Monday I spent, a lot of time understanding why index on the database wasn't working as it's supposed to be. Someday I might spend, 2 hours, making some kind of graphs. Then I would have a meeting with our CEO and he'd say, no, I don't like this kind of graph. Then I would, readjust. Then someday you might have some kind of big planning for 3 months when you just sit there and brainstorm the ideas, try things out. Sometimes I would just not do anything, sit there and read about new stuff and just try to do something out of the box. So there is no typical day. I would say like every day what's typical to me is that I come into the office, I drink coffee and then kind of let it go from there.
A real-life situation that would illustrate what is danger zone?
Real-life situation?
Yes.
Well, it's a hard question, right? But so real-life situation, for example, let's take you're doing simple regression model, right? And you have endogeneity, right? But you're not aware of that. But you heard from machine learning you can do least squares regression. You have like really nice R square. You're kind of, maybe your out of sample predictions work kind of all right, but you're not aware that your response variable is correlated with the model error. And you say to your boss that, yeah, I found that this variable, it is responsible for everything. But what endogeneity does to your model is that you get completely random model coefficients. So it might work in out-of-sample prediction, but in inferring how the system works and inferring what things cause each other and what effects they have on another, you would make a wrong decision. So this is like the first thing that came to me. So, and the real life example was a simple Simpson's paradox that I was talking about. So we saw like simple 2 tables, and we didn't know about Simpson's paradox, and we maybe would have just used these simple 2 statistics and may have not considered using other ones, and we would say that LeBron James is better than Michael Jordan. Well, I think Michael Jordan is better.
One last question.
I do believe that you have to test your models, and how often do you do, maybe you can give us an example.
So I started working in Oberlo 2 weeks ago, and we don't have any models so far. So I'm just trying to figure out how their business work and what kind of things I can help them with. Trying to monitor things, do some descriptive statistics. But when I was working in Adform, I was working with fraud detection, so we would run our model every day and then basically test it. So I would say it's daily, and like you wouldn't look at these metrics every day, but occasionally you would take a look. So if something goes wrong, you would tweak some parameters. But I don't think it really depends on the business case how often you should do the back testing.
Ačiū, Edgarai.